The state plane coordinate system is a set of 124 geographic zones or coordinate systems designed for specific regions of the United States. Each state contains one or more state plane zones, the boundaries of which usually follow county lines. There are 110 zones in the contiguous U.S., with 10 more in Alaska, 5 in Hawaii, and 1 for Puerto Rico and U.S. Virgin Islands. The system is widely used for geographic data by state and local governments. Its popularity is due to at least two factors. First, it uses a simple Cartesian coordinate system to specify locations rather than a more complex spherical coordinate system. By using the Cartesian coordinate system's simple XY coordinates, plane surveying methods can be used, speeding up and simplifying calculations. Second, the system is highly accurate within each zone. Outside the specific state plane zone, accuracy rapidly declines, thus the system is not useful for regional or national mapping. Most state plane zones are based on either a transverse Mercator projection or a Lambert conformal conic projection. The choice between the two map projections is based on the shape of the state and its zones. States that are long in the east-west direction are typically divided into zones that are also long east-west. These zones use the Lambert conformal conic projection because it is good at maintaining accuracy along an east-west axis. Due to the projection cone intersecting the Earth's surface along two lines of latitude, zones that are long in the north-south direction use the transverse Mercator projection because it is better at maintaining accuracy along a north-south axis. Due to the circumference of the projection cylinder being oriented along a meridian of longitude, the panhandle of Alaska, whose maximum dimension is on a diagonal, uses an oblique Mercator projection, which minimizes the combined error in the x and y directions. History. In 1933, the North Carolina Department of Transportation asked the Coast and Geodetic Survey to assist in creating a comprehensive method for converting curvilinear coordinates to a user-friendly, two-dimensional Cartesian coordinate system. This request developed into the state plane coordinate system, which is now the most widely used expression of coordinate information in local and regional surveying and mapping applications in the United States and its territories. It has been revised several times since then, when computers began to be used for mapping and GIS. The state plane system's Cartesian grid system and simplified calculations made spatial processing faster and spatial data easier to work with. Even though computer processing power has improved radically since the early days of GIS, the size of spatial data sets and the complexity of geoprocessing tasks being demanded of computers have also increased. Thus, the state plane coordinate system is still useful. Originally, the state plane coordinate systems were based on the North American datum of 1927. Later, the more accurate North American datum of 1983 became the standard. More recently, there has been an effort to increase the accuracy of the 83 Namibian dollars datum using technology that was not available in 1983. These efforts are known as High Accuracy Reference Network or High Precision GPS Network. In addition, the basic unit of distance used is sometimes feet and sometimes meters. Thus, a fully described coordinate system often looks something like Washington State Plane North 83 Namibian dollars Han, U.S. Survey feet. This information is needed in order to accurately transform data from one coordinate system to another. Problems. The main problem with the state plane coordinate system is that each zone uses a different coordinate system. This is not a major problem as long as one's needs are within the boundaries of a given state plane zone, as is the case with most county and city governments. However, the need to transform spatial data from one coordinate system to another can be burdensome. Sometimes a regional area of interest, such as the metropolitan area covering several counties, crosses a state plane zone boundary. The Seattle metropolitan area is an example of this. King County, which includes the city of Seattle, uses the Washington state plane north coordinate system, while Pierce County, which includes the city of Tacoma, uses Washington state plane south. Thus, any regional agency that wants to combine regional data from a local government has to transform at least some data into a common coordinate system.